Hello everyone, this is Banu Prakash from Andhra Pradesh. I have total 14 years experience in the chemistry. At present, I'm working as a senior faculty in Sri Chaitanya organization at Rajahmundry. Today, I want to discuss about the some brief discussion about the quantum number concept. The concept was the present in atomic structure. So first of all, I want to discuss the what are the main importance of the quantum number. With the help of the quantum numbers, with the help of the quantum number, to find out the exact position of the electron present in the atom. Simply, I can say that with the help of the quantum numbers, the address of the electron can be find out. Address of the electron. But how can it is possible? Address of electron can be find out. But how can it is possible to find out? For example, we look after the our address. Each and every person having this the postal address, either temporary or permanent address will be there. In that address, it can mention the one number. As you know about that number, so called pin code, so called as a pin code. In that pin code, the total 6 digits will be there. For example, in my postal address, my pin code number is 533221, and the total it carrying the how many numbers? Total 6 numbers. That the total entire digits will be contained in six. In this, the first digit is indicated the region. It is indicated the region. Either our India is divided to 4 regions, like East region, West region, South region, like North region. Particularly, the 5 stands for the South region, and the second digit is indicated the sub regions, and the third digit is indicated. The third digit is indicated the district. It is indicated the district. In that district, the which mandal that particularly indicated the mandal, and remaining last 2 digits are indicated the particular post office code. It is indicated the particular village, the post office, the code can be recognized. And with the help of this all the 6 digit number, very easy to trace out the our address in India. And particularly the pin code is belongs to the particular village post office only. It is indicated in India, in which region and which sub region and which district. And in particular in that district, there's so many mandals will be there, in which mandal that particularly belongs to. And in each and every mandal, number of post offices will be there. So each post office is having some particular codes. So with the help of the pin code, how can it is recognized the particular place? Like that manner, in atom, the exact number of the exact position or location of the electron can be traced out on based upon the our quantum numbers. So that is the main importance of the quantum number. And if you know about the all the quantum numbers, very easy to identify the electron is belongs to which stationary orbit, that electron is belongs to which subshell, and which orbital, what is the shape of the orbital, and orientation of the orbital, the particular electron, and what is the spin of the electron. These all values can be easy to identify on based upon the particular quantum numbers only. So let me discuss about the remaining part of the our topic, quantum numbers. How many quantum numbers you can identify? The total 4 quantum numbers. The first one is known as the principal quantum number. The principal quantum number was simply denoted by the letter small n. It is denoted by the small n. And second one, azimuthal quantum number. It is also known as the angular momentum quantum number also. That quantum number was denoted by the small l. Azimuthal quantum number, also called as the angular momentum quantum number. And the third one, magnetic quantum number. That number was indicated by the ML, LML. And last quantum number was known as the spin quantum number. This can be represented by the letter MS. So total in our quantum numbers, the address of the electron, the 4 digits. What are the digits? Not digit, it is a quantum number. So what are the quantum number? N and L, ML, and MS. So these four will be called as the quantum number. Simply I can say the digits of the address of the electron. Okay now. So now individually one by one quantum number and what is the significance of the each quantum number, let it be reveal the remaining part of the our lesson. So what is the first quantum number is called? What is the first quantum number is called? Principal quantum number. So it can represented by the what is the letter? Small n. So what is the principal quantum number? The principal, as you know about the Niels Bohr. Niels Bohr. This quantum number, what is the main importance? If you know about the n value, it is indicated the name of the stationary shell, the main shell. It is indicated the main shell. If you know about the n value, according to the Bohr mathematical derivation, with the help of the radius and energy calculation, and based upon the particular information, we can easy to find out the size of the orbit, the size of the orbit, and the energy of the particular orbit also can be calculated. Okay, now what are the values? What are the values of n? N values are and 4, like etc. So if n is equal to 1, it is known as the K shell. So what is the n is equal to 1 is called K shell. The n is equal to 1, that is the first orbit. It is indicated the first orbit. N is equal to 1, it is known as the first orbit. It is also known as the K shell. If n is equal to 2, it is known as the second orbit. It is known as the second orbit. It is known as the L shell. N is equal to 3, it is known as the third orbit. Third orbit, it is also known as the M shell. So what is the orbit means? Orbit is entirely different from the orbital. That orbit is indicated the path of the electron. The path of the electron. The electron will be revolved around the nucleus. That path will be called as the orbit. But orbital is an entirely different term of orbit. Okay, now, like n is equal to 4, it is known as the fourth orbit. It is known as the fourth orbit. It is also known as the N shell. It is known as the N shell. Okay, now, and with the help of the principal quantum number, with the help of the principal quantum number, the energy of the particular orbit, the way the electron will be the present, that particular electron, the energy also will be found out. At the same time, that is size, that is the radius of the particular orbit also can be calculated. If n values are increases, if n value can increase, if n values are increases, that r value also will be, that is the radius of the particular orbit also will be increases. Like r1 is less than, r2 is less than, r3 is less than, like etc. For example, it is the third orbit, like etc. Here n is equal to, it is n is equal to 1, n is equal to 2, n is equal to 3. So the distance between the nucleus to that orbit, it is called the radius. The r1, r2, r3, like etc. R1 is less than the r2 value is less than r3 value. And when n values are increases, the radius of the particular orbit also will be increases. And each orbit, in each stationary orbit, the electron can be revolved around the particular energy that can represent it like E1, like E2, like E3, like. And if n value is increases, the energy, the magnitude of the energy also will be increases. Okay, now, like E1 is less than, E2 is less than, like E3 is less than, like etc. Okay, now, and the difference between the energies like delta E1, delta E2, delta E3. Okay, now, the energy separation between two shells will be decreases. The n value is increases, the delta E value will be decreased. Delta E means like E2 minus E1 value is more greater than and compared to E3 minus E2 greater than E4 minus E3. That is simply that the delta E1 is more value when compared to delta E2 value when compared to delta E3 value, like etc. And when principal quantum number value is increases, the radius of the orbit is increases. And principal quantum number is increases, the magnitude of the energy also will be increases. And principal quantum number will be increases, the energy separation between two shells will be decreases. The energy separation between two shells, that is a delta E1, delta E2, delta E3, those values will be decreased. So that is the main importance of the principal quantum number. The next quantum number is called as the angular momentum quantum number. It is also known as azimuthal quantum number. Okay, now what is the second quantum number is called? Azimuthal quantum number. It is also known as the angular momentum quantum number. Okay, now what is the angular momentum quantum number can be represented by the L. So that angular momentum quantum number was introduced the Sommerfeld. The Sommerfeld was introduced this quantum number. Okay, if you know about the azimuthal quantum number or angular momentum quantum number, what is the additional information? If you know about the L values, particularly L values are purely depends upon the principal quantum number, and without knowing of N value, you cannot able to describe the L values, and the L values are purely depends upon the principal quantum number, and each L value, N value, the azimuthal quantum number can be represented. So what are the L values? L values are 0, like 1, like 2, like etc. up to N minus 1. So what are the L values? 0, 1, 2, 3, like etc. N minus 1. If you know about the L values, the L value is mainly indicated the substationary orbits. That is indicated the subshells. If you know, find out. As you know about the subshells and their shapes also. Okay, now. So what are those values? What are those values? For example, N is equal to 1. That is called K shell. So what is the L value? 0 to N minus 1. So N is equal to 1, 0, like 1, 2, 3, like etc. Like N minus 1. N minus 1 means 1 minus 1, 0. That is a 0 to 0 means that N is equal to 1. Only one subshell is there. Only one subshell is there. That is L is equal to 0. That L is equal to 0. That subshell is called as the S subshell. That will be called as the S subshell. And N is equal to 2. That is K, L shell having 0, 1, 2, 3, like etc. N minus 1. That is 2 minus 1. 2 minus 1 is the 1. That is total 2 subshells. Total 2 subshells are present. That is L is equal to 0 and L is equal to 1. L is equal to 0. That is S orbital. But what is the difference between the above S subshell and below S subshell? It is a 1s subshell. It is 2s and 2p. So what is the difference between 1s and 2s? What is the difference between 1s and 2s? The 1s subshell means the S subshell present in the first orbit, and 2s means the S subshell present in the second orbit. That is one of the difference. And another difference, when N values will be increases, the L value will be same. The size of the orbit and energy also will be the different. But how can it is? Let me explain in later. And N is equal to 3. That is M shell. M shell having total 3 subshells are present. So what are the 3 subshells? What are the 3 subshells? L is equal to 0, L is equal to 1, L is equal to 2. Because 0, 1, and N minus 1. That is a 3 minus 1. 3 minus 1 is equal to 2. That 0 to 0, 1, 2. Total 3 values. So that is 3s, 3p, and 3d. Total 3 subshell will be present. Like that, N is equal to 4. That is the N shell having total how many subshell? N number of subshells. Total N means N value is the 4. So N number means the 4 subshells will be present. So what are the 4 subshells? What are the 4 subshells? L is equal to 0, L is equal to 1, L is equal to 2, L is equal to 3. That is 4s and 4p and 4d and 4f. The total 4 subshells will be present. So you can observe this all the information. Each and every L value, the purely depends upon the principal quantum number. And you know the principal quantum number, then only you can write the L values. Okay, now. But what is the difference between different subshells? What are the difference between the different subshell? For example, the energy order of in same main shell. Energy order of the same main shell. What is the energy order? Energy order of same main shell. That is, this is the order. S subshell having lower energy when compared to P, when compared to D, when compared to the F subshell. Okay. And second one, the subshell having the equal L values. Same, the L value is the same. L value is the same. The N value is different. What is the observation? L value is the same. For example, in L is equal to L is equal to 3. L is equal to 3 means 0, 1, 2, 3. That is F subshell. The F subshell means the 4F, like 5F, 6F, like 7F. Okay, now here what is the energy order and what is the shape? Like 3D, 4D, like 5D, like 6D. What is the different you can observe? Like 1S, 2S, and 3S, and 4S. What is the difference between 1S and 2S and 3S and 4S? So these all are having the L value is equal to 0 only. Okay, now L is equal to 0. But 1S and 2S and 3S and the 4S, what is the difference? The S subshell present in the first orbit and second orbit and third orbit and fourth orbit. And that means the S orbital, as you know, S orbital is a spherical shape. S orbitals are the spherical shape. The size of the orbit, the size of the subshell will be different. The 1S subshell somewhat small size. The 2S is somewhat bigger. And the 3S subshell somewhat bigger. And the 4S subshell somewhat bigger. And then L value the same. The N value the vary. What is the difference? You notice that the size of the particular subshell will be different. And also energy also. The energy order also. 1S is less than, 2S is less than, 3S is less than, like 4S. So here, what is my conclusion? The subshell having the equal L values. The subshell having the same L value, but different N values. The shape of the shape is the same. The size of the particular subshell is the vary. The size will be, the size of the particular subshell is increased at the same time. At the same time, energy of the particular subshell also will be increases. So what is the condition? L values are the same, N values are the different. And the same L value, different N value, the size of the particular subshell is increases, energy of the particular subshell also will be increases. Okay, now so on based upon these first two quantum numbers, like principal quantum number and azimuthal quantum number. Once look at the diagram, it is a nucleus of the orbit and the first orbit and the second orbit, and it is the fourth orbit, like fourth orbit. Here n is equal to 1, that is called K shell. N is equal to 2, L shell. N is equal to 3, it is called M shell. N is equal to 4, it is called N shell. N shell. And each main shell, the energy of the particular electron will be constant. That is the reason that particular orbit also known as stationary orbit. Why? Because those orbits will be called stationary orbit, because the electron can be revolved on the particular orbit, neither lose their electron, neither gain their neither lose their energy, neither gain the energy. So that is the reason that particular orbit or shells will be called as the stationary energy levels are stationary orbit. So that energy can be represented like E1 and E2 and E3, like and R2 and R3 and R4. So N values are increases, the energy of the particular orbit will be increases, and the radius of the particular orbit also will be increases. Okay, now according to the first quantum number. And second quantum number, N is equal to 1, the K shell having how many subshell? N number of the subshell. The K shell having only one subshell, that is called 1s subshell. And the second orbit is N is equal to 2, the L shell having two subshell. So what are the subshell? The 2s and 2p. And the third orbit having the three subshell, those are 3s and 3p and 3d. The fourth shell is containing the four subshell. What are the subshells? 4s subshell and 4p and 4d and 4f. Okay, now once look at that, the 1s and 2s and 3s and 4s. So 1s, 2s, 3s and 4s, what is the common and what is the different points? These are 4, 1s and 2s and 3s and 4s. These all are spherical in shape because s orbital are the spherical shape. But 1s is the spherical, 2s also spherical, 3s also spherical, 4s also spherical shape. But what is the difference? That s subshell is present in the first orbit, s orbital present in the second orbit, s subshell is present in the third orbit, s subshell is present in the fourth orbit. And that means the L is equal to 0 and L value is the same, but N value here, first orbit 1 and second orbit 2, third orbit 3, fourth orbit 4. The same L value, the N value will be different. The shape of the particular orbital will be vary. The shape, not shape. The size of the particular subshell will be increased. The size will be increased, and moreover, energy of the particular subshell also will be increased. So that is the conclusion points about the first two quantum numbers. And moreover, number of electrons also finding with the small formulas. In particularly each main energy or stationary orbit, that number of electrons, a very simple formula, that is a 2n square. What is the formula? 2n square. What is the 2n square formula is indicated? The number of electrons present in each main shell. That formula. For example, n is equal to 1. So substitute the formula, that 2 into 1 square, that is a 2 electron can be present. That is a K shell having how many electrons are accumulated? The K shell having only 2 electrons are accumulated. Like that, n is equal to 2. That 2 into 2 square. 2 square is the 4. 4 into 2, 8. And the second orbit, that is M shell having total 8 electrons can be accumulated. The second shell having 8 electrons. Like n is equal to 3. 2 into 3 square. The 3 square means 9. 9 into 2. Total 18 electrons can be accumulated in the third orbit. Like n is equal to 4. The 2 into 4 square. Total 4 square is 16. 16 into 2. Total 32 electrons are accumulated in the fourth orbit, like etc. That is number of electrons are accumulated in each main energy. And one more formula I want to introduce, that is 2 into 2l plus 1. So what is the 2 into 2l plus 1? That number of electrons accumulated in each subshell. Okay. And how many number of electrons are present in the each subshell? That is a 2 into 2l plus 1 number of electrons. For example, L is equal to 0. That is S subshell are having how many electron? 2 into 0 plus 1. 2 into 0, 0, 0 plus 1, 1, no? 1 into 2, that is a 2. And S subshells are accumulated only 2 electrons. The S subshell containing the 2 electrons. Like L is equal to 1. That is called P subshell. The P subshell are having the how many electron? Maximum 2 into 1 plus 1. 2 into 1, 2. 2 plus 1, 3. 3 into 2. Total 6 electrons. The P subshell containing the 6 electrons. Like L is equal to 3. That is called D subshell. The 2 into 1. The 2 into 2, 4. 4 into 4 plus 1. 5. 5 into 2. Total 10 electrons. The D subshell having how many electrons? The 10 electrons. Like L is equal to 3, that is called F subshell. F subshell having 2 into 3 plus 1. 2 into 3, 6. So 6 plus 1, 7. 7 into 2, total 14 electrons. So this formula is indicated the number of electrons present in the each subshell. The 2n square formula is indicated the number of electrons present in the particular stationary orbit. The main shell on electrons are indicated. Okay, that is the difference between both the formulas. And next, the third quantum number. So what is the third quantum number is called? The third quantum number is called as the magnetic quantum number. The magnetic quantum number can be represented by the, what is the letter? ML. The magnetic quantum number can be represented by the letter ML. That magnetic quantum number was introduced by the scientist Linde. Okay, now that magnetic quantum number was introduced by the Linde, and magnetic quantum number values is purely depends upon the azimuthal quantum number. Okay, if you know the L value, then only find out the ML value. Why? Because ML values are minus L2 plus L, including 0. What are the M values? Minus L2 plus L, including the 0. That ML values. What is the main significance of the ML values? As you know about the Stark effect or Zeeman effect. So what is the Stark effect or Zeeman effect? Under the influence of magnetic field or electrical field, you can apply that each spectrum line is further split into small lines. That is called as the splitting of spectrum lines. What is the splitting of spectrum lines mean? Splitting of spectral lines. It is also called as the fine structure, and it is also known as the fine structure. And when magnetic field or electrical field can be applied under the influence of magnetic field or electrical field, each subshell is further divided into subdivided into orbitals, and each subshell is divided into what is that? Orbitals. So what is the orbitals means? It is entirely different from the orbit. Orbit is indicated the path of the electron, but what is the orbital? Orbitals are the three-dimensional space. It is the three-dimensional region where the electrons can be the present. Okay, now as per the definition point of view, what is the orbital? The probability of finding of electron in the maximum, that regions will be called as the orbitals. Okay, now that magnetic quantum number mainly is indicated the orientation of the electron, that is the distribution of electron in each orbital. So what is the main significance of the magnetic quantum number? Orientation of the electron in an orbital. In an orbital can be explained with the help of the magnetic quantum number. And when under the influence of the magnetic field, each subshell is further divided into some orbitals. Okay, now what are the orbital? As you know about the definition. So what is the definition? The probability of finding of electrons are the maximum. And simply I can say that the where electrons can be located, it is indicated as three-dimensional region, the three-dimensional space, the electrons presence. Okay, now. So orbitals are further divided into s orbital, like s orbital, p orbital, like d orbital, and f orbitals. So those are the different types of the orbital. For example, L is equal to 0, that is known S subshell. S subshell, how many ml values? So ml values are minus L to plus L. Minus L to plus L. Just I want to show the one diagram. It is 0, like x coordinate and y coordinates, like you can imagine. It is a 1, 2, 3. It is -1 and -2, like -3, like -4, like etc. So once look at the ml values. ML values are minus L to plus L, including 0. For suppose L is equal to 0, that S subshell minus 0 to plus 0. 0 to 0 means only 0, and only ML having only one value, that is the 0. That is S subshell having the only one orbital, that is S orbital. Like L is equal to 1, that is called P subshell. The P subshell L value is 1. So -1 to +1. -1 to +1 means -1, 0, and 1. That is a +1. And the total ML having the total 3 values. That is a -1. That is the 3 orientation. -1, 0, and +1. Okay, now the P subshell having the 3 orientation. So what is the 3 orientation? The one is known as the px orbital, other one is known as the py orbital, and other one is known as the pz. Px, py, pz. But in generally in arbitrarily, the pz orbital is considered as a 0. It is considered as a 0. So remaining px and py may be +1, maybe -1, but it's not necessary condition for px is -1, py is the +1, pz is the 0. But you can ordinarily you can take pz is considered as a 0, but px and py may be negative value, may be positive value. Okay, it's not essential condition. It is not essential point for the way of representation. Like L is equal to 2. What is L is equal to 2? D subshell. The D subshell having L value 2. So -2 to +2. -2 to +2 means -2, -1, 0, +1, and +2. So total ML having how many values? -2, -1, 0, and +1, and +2. The total 5 values. And so those orientations are represented by the dxy, dyz, dxz, dx square minus y square, and dz square. Generally, dz square is considered as a 0. The remaining one is -1, -2, -1, +1, and +2. Like f orbital having the similar manner, total 7 values are there. That is -3 to total +3. The total 7 values can be present. Okay, now it is also having the simple formula 2l plus 1 number of orbitals can be present. For example, L is equal to 0. L is equal to 0, 2l plus 1. The 2l plus 1 means 2 into 0 plus 1. 2 into 0, 0, 0 plus 1, 1. And L is equal to 0. S sub shall having only one orientation. Like L is equal to 1. How many orientations? Just substitute the above formula. The 2 into 1 plus 1. Total 3 orientation. Those are called px orientation, and along the y-axis py orientation and pz orientation. And L is equal to 2. How many orientation? 2 into 2 plus 1. Total 5 orientation. What are the 5 orientation? dxy, dyz, dxz, dx square minus y square, and dz square. Okay, now here lower limit is a plus of and upper limit is a minus of. Okay, now this is about the magnetic quantum number. And next, last quantum number is called as the spin quantum number. It can represented by the letter ms. The spin quantum number was introduced by the two scientists. One is known as the Uhlenbeck, and the other scientist was known as the Goudsmit. Uhlenbeck and Goudsmit, both are the two scientists. Okay, now what is the spin quantum number? The spin quantum number, only the two values. One is known as the plus of and the other one is known as the minus of. So what is the ms quantum numbers are indicated? Spin quantum number is indicated the spin of the electron in particular orbital. It is indicated the spin of electron, the spin of the electron in the orbital. The electron can be revolved around the nucleus in the particular spin. Either it is orientation, either clockwise orientation, the clockwise spin, either it is anti-clockwise spin. So particularly the clockwise spin, it is indicated the plus of. Okay, now particularly the clockwise spin, the spin of the electron can be represented in particularly clockwise spin is represented the s value plus of, generally denoted by the upward direction arrow mark, and the anti-clockwise direction, that electron can be revolved anti-clockwise spin, it can represented the s is equal to minus of. So it is indicated the downward arrow, it can be indicated. The upward arrow is indicated clockwise spin, and downward arrow is indicated the anti-clockwise spin of the electrons are indicated. Okay, now so finally you can conclude that n value and ml value and ms value and n value, L value, and ml value, ms value, these four are the main important quantum numbers or digits for to find the exact location of the electron. Okay, now for example, as you know about the sodium, what is the sodium differentiation electron? Sodium, what is the electronic configuration of the sodium? What is the electronic configuration of the sodium? The sodium electronic configuration is 1s2, 2s2, 2p6, 3s1. So the last electron, the differentiating electron is called the last electron. I mentioned the four quantum numbers of the last electron, differentiating electron of the sodium. As you know about that representation is called NLX method. So here what is the N stands for? Principal quantum number. And here L is indicated the azimuthal quantum number, and X is indicates the number of electrons, number of the electron. This method is called NLX method. Is one of the way of representation of the each and every electron in electronic configuration. So the last electron is 3s1. So what is the meaning of 3s1? That left hand side coefficient 3, the 3 is indicated n is equal to 3. And what is the S stands for? S means L is equal to 0. and here one electron, only one electron. In ordinal or in generally, the first electron, the spin is generally considered as a the plus of the considered as that. It is considered as a plus of, and L is equal to 0, as you know, ML value. ML values are minus L to plus L. That is a minus 0 to plus 0 means only the 0. So what is the last electron? 4 quantum numbers. What are the last electron? 4 quantum numbers. N value and L value and ML value, MS value of the 3s1, the differentiating electron of the sodium, the 3, 0, 0, and the plus of. It not considered as a plus of, maybe it is considered as a minus of also. Okay, now maybe it is a clockwise spin, either anti-clockwise, but in generally it can consider as a spin of the first electron, generally represented as a clockwise spin only. Okay, now. But suppose I want to do the one more problem regarding the quantum number concept. Which of the following is not a possible set? He's asking about which of the following is not a possible set, not possible set. So N value and L value and ML value, MS value is given. Option A, 2, 1, 0 is the plus of, and option B, 2, 0, minus 1 and plus of, and option C, 3, 0, 0 and minus of, and option D, 3, 1, minus 1 and plus 1 by 2. So he is asking which of the following is not a possible set. Which of the following is not a possible set. But how to do the problem? How it is? As you know, n is equal to 2. N is equal to 2. What are the L values? 0 to n minus 1. So it is a 2. 2 minus 1, 1. So 0 or 1. So 1 is the correct option. If L is equal to 1, ML values are minus 1 to plus 1, including 0. So 0 is including. So it is also correct. Maybe it is a plus of or minus of. So this option is a correct option. But he is asking not a possible set. If n is equal to 2, L value, maybe it is a 0. If L value is a 0, it is not possible for minus 1, because L is equal to 0, ML value compulsory 0 only. So it is a wrong set. Okay, now once check the remaining 3 options also. N is equal to 3, L is equal to, L value maybe 0, maybe 1, maybe 2. So it is a correct. L is equal to 0, ML is equal to 0 only. Maybe plus of or minus of. It is also correct. Again, N is equal to 3, L is equal to 1. It is a possible. If it is a 1, minus 1 to plus 1. So minus 1, it is a correct. It is also correct. So the wrong not possible set is option B is the correct. Option B is the correct. So finally, I can conclude that all the quantum numbers. So I can explain the first point. With the help of the quantum numbers, the exact address of the electron can be found out. So how can it is possible to find out the electron location with the help of all the quantum number? So make sure all of you understood about the today's topic. So thank you. Thank you all.